Assalamualaikum warahmatullahi wabarakatuh. My name is Yusmal Hakim bin Kamal. Today I would like to present about design of experiment for car blind spot detection evaluation for car and pedestrian. This is our project abstract. SS1 driver assistance system, also known as ADAS, become more common in vehicle. It is critical to evaluate and optimize key safety functions such as blind spot recognition. This study employs a systematic design of experiment technique to determine how successfully blind spot detection system detect cars and pedestrians. The test imitate real-world driving circumstances by varying vehicle types, speed, and weather condition. A range of cars and people are employed to test the system functionality in various settings. Key performance indicators including as accuracy, reaction time, and false alarm are recorded and statistically analyzed to discover key system affecting elements. The objective is to better understand the strengths and limit of blind spot detection system in order to improve their safety and dependability. The DOE framework provides a systematic technique for evaluating and improving blind spot detection technology in the future. The findings may lead to advancements in vehicle safety system. This is the contents that are included in our presentation. For introduction, every year cars are updated with new features to improve driving and safety. Blind spot systems are one example. There are two kinds. Detection. Blind spot detection (BSD) uses sensors to detect vehicles in adjacent lanes that drivers can't see. It wants drivers to help with safe lane changes. Non-detection blind spot visualization (BSV) display an image to the driver. BSD systems are designed to detect highway vehicles, not bikes, motorcycle, people, or animal. Many only work above a threshold speed, typically 5 to 20 km per hour. BSV display an image to the driver from 0 km per hour up to the car's maximum speed. Understanding the capabilities and limitations of different blind spot technology can lead to safer driving. Next is our purpose and objective. The goal is to improve road safety. Drivers have limited visibility and often overlook blind spot when changing lanes. This technology uses sensors to detect vehicles in blind spot and alert drivers. The aim is to give drivers real-time information so they can make safer decisions. This could reduce accidents, especially during lane changes and merging. Overall, car blind spot detection strive to enhance road safety by addressing the limitation of drivers' vision. The project seeks to develop a reliable system that warns drivers about obstacles they cannot see directly. By improving awareness, it can help prevent collision and save life. Next is our literature review. Blind spot monitoring system detect vehicle in driver's blind spot. Warning can be visual, audible, vibrating, and tactile. System may also have rear cross traffic alert to detect approaching vehicles when backing up. With more focus on driving safety, advanced driver assistance systems like blind spot monitoring are becoming more popular. They can improve safety and prevent accidents, especially when changing lanes. Research use vision and radar technology to detect vehicles entering blind spot. Studies have developed systems that monitor blind spot on the side and rear of vehicles. The goal is to alert driver and give enough reaction time to avoid collision. Key consideration for feature improvement: enhance performance in low light condition by combining camera and sensor data. Expand monitoring with side and rear camera or 360 camera that are popular nowadays. Develop reasoning to handle more complex scenarios beyond vehicle driving in parallel. This is, if you look here, this is our scene of experiment. That's all for me. I will give Zul to continue with this next slide, which is design of experiment. Thank you.
Okay, I will continue the design of experiment. First, we select a test vehicle. Next, the test environment for the experiment that day. Next is a vehicle scenario, and then blind spot configuration. Next is weather condition for that experiment. Uh, Next is speed variability, and after that we collect data, and then analysis, statistical data, and then we create the report. Okay, next for the procedure, we make a preparation, and then system activation. After that we stationary object test, and then test car variable speed car test, and then we collecting the data, and then make a documentation. After that, if necessary, we make a adjustment. For the equipment we use is two car, which is Toyota Yaris and the Pro2 Asia, and con live time lapse, and then smartphone. Okay, next the scenes of experiment. This controlled experiment assesses driver reaction time to blind spot using three participants with varying experiment. Driver were tested on right and left blind spot at 25 to 30 km per hour of consistency. The test involved reaction to simulate overtaking and blind spot. Reaction time were recorded for analysis. Revenge time were calculated per site to identify pattern. Okay, next is result were visualized in chart and table. Insight for the finding and recommendation to improve reaction time we provide. Strict inhibits were followed, ensuring consent and privacy. The controlled condition and analysis provided valuable data on driver blind spot response and giving safety recommendation.
Hi, Assalamualaikum. My name is Khairul Amirin bin Rasri, and for my part, I will going to talk about the result that we have been gained from the lab experiment. So, the given tasks are to record the driver reaction time to notice the blind spot indicator. And for our group, we have decided to use 3 drivers for this experiment. And let's move to the result. For driver 1, it seems here that he's taking more time to notice the blind spot indicator. This caused by various factors. As a feedback that we gained from the driver 1, it can be seems that the driver 1 have less experience driving a car that have blind spot indicator. And for driver 2, the reaction time is the shortest. And when we ask about why they can notice them in a short time, it can be seen that the driver 2 have a lot of experience while driving a car that have blind spot indicator. So it's natural for them to react on time. Same as driver 3, as their vehicle have a blind spot indication light. So that's why they can notice them shortly after its light. And let's move to the next part. Okay, then let's discuss and analyze the graph that have been shown. As you can see visually, most of the driver took longer to react on the right side of the blind spot indicator. This caused by various factors, as they need to focus on the driving rather than on the side mirror. While looking at the side mirror, it can distract them during driving. However, on the left sides, it seems easier for them to see the blind spot indicator. We are going to do comparison between the UN regulation and the reaction time that we have been recorded during the lab experiment. For UN regulation, the unexpected time from the driver to notice for the blind spot detection indicator, it must took less than 1.5 seconds. Not only that, the UN regulation also standardized that the reaction time of the sensor while vehicle pass through the blind spot, it should take less than 1 second for the blind spot the detection indicator to light. And let's move to the next part. For discussion, we can see all of the driver reaction time is less than 1 second. It means that all the driver are past the compliance for the detection experiment. It can be seen here that all the drivers using safety while driving. And let's move to the next part. To conclude this experiment, as we can see, different car manufacturers will give different reaction time for the driver to react on the blind spot indicator. This is caused by various factors such as the design of the blind spot detection indicator. As for Toyota Yaris, I think it's past the UN regulation because the design is very good. On the side mirror, the blind spot detection indicator blinks very bright, and the logo for the blink is really big, make the driver easy to notice when the light blinking. And not only that, it's proof that the car manufacturers nowadays very take safety really serious. They want to ensure the driver safety, and they will provide the effective safety technologies for them. And that's all from us. Thank you.